Welcome. You've reached the end of your day, and now you can let everything else fall away. Take a breath, let your shoulders drop. The world outside can wait. Tonight, we are travelling north to the edge of Europe, where winter was not just a season, but a test that arrived every year without fail. We are going to spend time with the people who lived there, communities scattered across Scandinavia during the centuries we now call the Viking Age. For months at a time, their world turned cold and dark. The sun barely rose above the horizon. Temperatures dropped well below freezing. Snow covered the ground and the roofs, the pathways between homes. In this environment, warmth was not a comfort. It was survival. And keeping an entire village warm required more than fire alone. It required design, cooperation, preparation, and knowledge passed quietly from one generation to the next. There were no dramatic inventions, no sudden breakthroughs, just careful observation of the world around them and the slow accumulation of methods that worked. Over the next while, we will move through these methods together. We will see how villages were built, how homes were insulated, how fires were kept alive, and how communities shared the work of staying warm. So settle in, let the story unfold at its own pace. The work of winter began long before the first snow. As summer faded and the light began to shorten, Viking communities turned their attention to preparation. There was no calendar date that marked the beginning of this work. People read the environment. They watched the angle of the sun, the behaviour of animals, the temperature of the wind coming off the sea. Autumn was the season of assessment. Villagers moved through their settlements with purpose, inspecting roofs, checking walls, counting stores. They walked the forest nearby, noting where dead wood had accumulated, which trees had fallen, where branches could be harvested without damaging living growth. Wood was the primary fuel. In regions where forests grew densely, communities had access to birch, pine, and oak. In more barren areas, driftwood collected along coastlines became valuable. Every piece was noted, evaluated, and eventually carried back to the village. The work was communal. Families coordinated their efforts, dividing tasks according to strength and skill. Younger men felled trees and hauled logs. Women and children gathered smaller branches, stripped bark, and sorted wood by size and dryness. Elders oversaw the process, ensuring that nothing was wasted and that supplies would last through the coldest months. Storage was deliberate. Wood was stacked under overhangs, covered with hides or woven mats to keep rain and snow from soaking it. Dry wood burned hotter and longer. Wet wood smouldered, produced excessive smoke, and wasted effort. The difference mattered. In regions where trees were scarce, peat became the alternative. Peat forms in wetlands, where plant material decays slowly in waterlogged soil. Over centuries it compresses into dense, dark layers that can be cut, dried, and burned. Harvesting peat required different tools and different timing. It was heavy, difficult to transport, and needed weeks of drying in the open air before it could be used. Communities that relied on peat developed rhythms around its collection. They cut it in late spring or early summer, when the ground was workable but not yet fully saturated. The blocks were stacked in low pyramids to allow air circulation. By autumn, if the weather had been favourable, the peat was dry enough to store. Fuel was not the only concern. Roofs needed inspection. Turf roofs, common across Scandinavia, required maintenance. The grass on top continued to grow through summer, and its roots held the soil layers together. But heavy rains could erode sections, and wind could peel back edges. Villagers walked their rooftops, pressing down loose areas, adding fresh turf where gaps had formed, ensuring that the insulation remained intact. Walls were checked for cracks. Longhouses were built with thick walls, often combining stone foundations with wooden frames filled in with packed earth, clay, or torr earth. Over time, settling and weathering created gaps. These were patched with fresh material, smoothed over and left to harden before the cold arrived. Doorways received particular attention. Entrances were points of vulnerability. Cold air could rush in whenever a door opened. Some longhouses had double-door systems, creating a small vestibule between the outside and the main living area. Others used angled entryways that forced incoming air to turn before reaching the hearth. Leather or heavy cloth hung over doorways added another barrier. Smoke vents in roofs were adjusted. During warmer months, vents stayed open to allow smoke from cooking fires to escape freely. In winter, these openings needed to be smaller, just large enough to release smoke, but not so large that heat poured out with it. Adjustable covers, often made from wood or woven material, could be shifted depending on wind direction and fire intensity. Animal shelters were prepared as well. Livestock, cattle, sheep, goats, pigs, would spend winter either inside the longhouse itself or in structures built directly adjacent. Their body heat contributed to the overall warmth of the dwelling, but only if they were positioned correctly and the space was managed to prevent excessive moisture buildup. Food stores were organised. Grain, dried fish, salted meat and preserved vegetables were moved into storage areas within or near the longhouse. Fermentation vessels, barrels of beer, mead or pickled goods were checked and sealed. Even the slow fermentation process generated a small amount of heat, a minor but noticeable contribution in an enclosed space. By the time the first real cold arrived, the village had transformed. Wood piles stood against every building. Roofs were thick and secure, walls were sealed, doorways were reinforced. Every household had completed the same set of tasks, following patterns learned in childhood and repeated every year. There was no celebration when the work was done, no formal acknowledgement. The reward was simply the knowledge that preparation had been thorough. The village was ready. The placement of a village was not arbitrary. Long before the first structure was built, the land itself was studied. Viking communities understood that survival depended on choosing the right location. The terrain shaped how wind moved, where water collected, how much sunlight reached the ground, and how cold settled during the night. Valleys offered protection. Hills on either side blocked the worst of the wind, creating pockets of relatively still air. Wind removes heat rapidly. A structure exposed on a hilltop loses warmth far faster than one nestled in a sheltered depression. Communities built in valleys whenever the land allowed it. But not all valleys were suitable. Low-lying areas where cold air pooled were avoided. Cold air is denser than warm air. It sinks, accumulating in the lowest points of the landscape. A village built in a valley floor might be protected from wind, but suffer from temperatures several degrees colder than a site just slightly higher on the slope. The ideal position was partway up a hillside, where shelter from wind was still present, but cold air drained away naturally. This placement also improved drainage for water, preventing the ground around homes from becoming waterlogged and frozen. Proximity to forest mattered. Fuel needed to be accessible, but distance had to be balanced against other needs. A village built too deep in the forest was shaded, receiving less direct sunlight during the short winter days. A village built too far from the trees required longer journeys to gather wood, exhausting effort that could be spent on other tasks. Coastlines presented their own considerations. Access to the sea meant fishing, trade, and the possibility of driftwood collection. But coastal areas were windier, and salt air corroded materials more quickly. Communities along the coast often built slightly inland, far enough to escape the worst of the wind but close enough to maintain their connection to the water. South-facing slopes received more sunlight. In Scandinavia, where winter sun barely clears the southern horizon, even a few degrees of slope angle made a measurable difference. Longhouses were oriented with their long axis running east to west when possible, maximising the southern exposure of the wall and roof. Natural windbreaks were utilised. Ridges, rock outcroppings, clusters of trees, any feature that disrupted wind flow was incorporated into the settlement plan. Buildings were positioned to take advantage of these barriers, creating layered zones of decreasing wind intensity as one moved from the edge of the village toward its centre. The spacing between structures also mattered. Buildings placed too far apart lost the benefit of shared warmth. Buildings placed too close together created hazards. If one roof caught fire, flames could spread quickly. The optimal distance varied depending on building size and materials, but generally longhouses were positioned near enough that their heat signatures overlapped without their walls touching. In some settlements, buildings were arranged in clusters around a central open area. This layout created a wind shadow in the middle, where the surrounding structures blocked airflow from multiple directions. The open space served as a gathering point during milder weather and as a shared work area during storms, when outdoor tasks still needed to be completed. Hillside construction sometimes involved partial excavation. Rather than building entirely above ground, communities dug into the slope, creating a foundation that was half buried. The earth on the uphill side acted as both structural support and insulation, wrapping around the back and sides of the longhouse. This method reduced the amount of material needed for walls and dramatically improved heat retention. Rock formations were incorporated when available. Large boulders or bedrock outcroppings became the back wall of a structure, eliminating the need to build that section entirely. Stone holds and releases heat slowly, stabilizing temperature fluctuations. A longhouse built against rock was colder initially, as the stone absorbed heat from the fire, but once the stone warmed, it radiated that heat back into the space for hours. Water sources were always nearby. Rivers, streams, or springs provided drinking water for people and animals, but proximity had limits. Villages avoided building directly next to fast-moving water, which created humidity and localized cold zones. A short walk to the water source was acceptable. Living on top of it was not. The land was also read for signs of previous occupation. If a site showed evidence of earlier settlement, post holes, remnants of stone foundations, unusually fertile soil from decomposed refuse, it suggested that others had found the location viable. Communities sometimes built on the same sites used by earlier generations, layering new structures over old foundations. Over time, the village itself altered the terrain. Trees were cleared for fuel and construction, changing wind patterns. Pathways were worn into the ground, creating defined routes between buildings. Refuse pits, animal pens, and garden plots reshaped the immediate environment. The settlement and the land adapted to each other, gradually becoming inseparable. By the time the cold months arrived, the village was not just built on the landscape, it had become part of it. The terrain's natural features and the community's constructed features worked together, creating a collective defense against winter. The longhouse was the core structure of Viking life. It was not a single design, but a general form adapted to local materials, climate, and family size. The common thread was its shape, long and narrow, often between 15 and 30 metres in length, and 5 to 8 metres in width. This proportioning was not decorative, it was functional. The elongated shape maximised usable space while minimising the exterior surface area exposed to cold. A compact square or circular building would have less interior room for the same amount of wall material. The longhouse stretched its volume efficiently, creating a large interior with relatively little external exposure. The structure was divided internally, though not always with solid partitions. The central area, running the length of the building, was the main living space. This is where the hearth was located, where meals were prepared, where people gathered. The outer edges, along both long walls, were raised platforms used for sleeping, storage, and work that required sitting or kneeling. Walls were thick. In forested regions, vertical posts of split timber formed the frame. Horizontal planks were fitted between the posts, sometimes overlapping, like roof shingles to shed water. Gaps between planks were filled with moss, clay, or wadded wool. In areas with less wood, stone formed the lower portion of the wall, with turf or timber completing the upper sections. The thickness of the wall mattered more than the material. A wall half a metre thick created substantial resistance to heat loss. Cold air penetrating the outer surface moved slowly through the dense layers, losing energy before reaching the interior. Warmth from the hearth trying to escape encountered the same resistance, trapped inside the dwelling. Roofs were steep, designed to shed snow. A flat roof would accumulate weight, risking collapse. A steep pitch allowed snow to slide off or at least distribute unevenly, concentrating in areas where the structure could support it. The roof framing consisted of paired timbers leaning together at the top, supported by a ridgepole running the length of the building. Crossbeams tied the walls together and provided lateral support. Turf covered most roofs. Layers of sod were laid over a base of birch bark or wooden planks, grass side up. The roots of the grass held the soil together, preventing erosion. Over time, the grass continued to grow, reinforcing the roof further. Turf was heavy but effective. It insulated against cold, absorbed sound, and regulated moisture. In summer, it kept the interior cool. In winter, it kept warmth inside. Openings were minimal. Some longhouses had no windows at all. Those that did kept them small, narrow slits near the roofline that allowed light and air, but little heat loss. These openings could be covered with shutters, wooden panels, or stretched animal membranes that let in diffused light while blocking wind. The entrance was always a point of compromise. people and animals needed to move in and out, but every opening was a thermal liability. Doorways were kept low and narrow, forcing anyone entering to stoop. This reduced the volume of cold air that could rush in at once. Some entrances had a short tunnel-like passage before the main interior, creating an airlock effect. When the outer door opened, the inner door remained closed. When the outer door closed, the inner door could be opened, limiting the time both were open simultaneously. Smoke vents punctured the roof at intervals. These were not chimneys in the later sense. No vertical flue channeled smoke upward. Instead, openings in the roof allowed smoke to drift out naturally, pulled by wind passing over the top of the building and by the heat of the smoke itself. The placement of these vents was adjusted seasonally. In winter, they were partially covered to reduce heat loss while still allowing enough draft to keep the interior breathable. The interior was dark, firelight from the central hearth provided the primary illumination. Oil lamps, small dishes of animal fat with a wick, supplemented the hearth when needed, but their light was faint and flickering. Eyes adjusted. Over time, occupants became accustomed to navigating in near darkness, relying on memory and the faint glow of embers. The floor was earth, packed hard from years of use. In some longhouses, flat stones were laid near the hearth to create a more stable surface for cooking. Elsewhere, wooden planks covered high traffic areas. The floor itself provided thermal mass. During the day, it absorbed heat from the fire, and at night, it released that heat slowly back into the space. Raised sleeping platforms lined both long walls. These were built at roughly knee height, elevating sleepers above the coldest air, which settled near the floor. The space beneath the platforms was used for storage, barrels, baskets, tools, animal feed. The platform surfaces were covered with furs, woven mats, or layers of cloth, creating insulation between the sleeper and the wooden surface. The hearth ran down the centre of the structure. It was not a contained fireplace but an elongated trench or raised stone platform where wood burned along much of the building's length. This distribution of heat was more effective than a single concentrated fire. Every part of the interior received warmth, and people could position themselves closer or farther from the flames, depending on their needs. Posts supported the roof and divided the interior into bays. These vertical timbers were thick, often entire tree trunks with the bark removed. Over decades, smoke blackened them, and the wood became hard and dense from constant exposure to heat and moisture. These posts were structural but also symbolic. Some were carved, marking the household's identity and continuity across generations. The longhouse was not just shelter, it was a carefully tuned system. Every element, walls, roof, floor, hearth, vents, doors, worked together to manage heat, moisture, light and airflow. The building itself was a tool refined over centuries designed to keep people alive through winter. Turf was everywhere. It covered roofs, reinforced walls and sometimes formed entire structures. Using turf as a building material was not unique to Scandinavia, but the Vikings refined its application to a degree few other cultures matched. Turf is simply soil held together by the roots of grass and other plants. It forms naturally in meadows and pastures, where vegetation grows densely and the root systems interweave. Cutting turf involves slicing through this layer horizontally, removing rectangular blocks that can be lifted and transported. The process began in late spring or early summer. The ground needed to be moist enough that the turf held together, but dry enough that it could be cut cleanly. A specialised tool, a long, flat blade attached to a wooden handle, was used to slice beneath the root layer. Each block was roughly 1/2 metre long, 1/4 metre wide, and as thick as the root depth allowed, usually between 10 and 15 centimetres. These blocks were heavy. Wet turf weighed more than dry turf, but dry turf was brittle and prone to crumbling. Freshly cut blocks were left in place for a few days to lose some moisture, then stacked carefully to continue drying without breaking apart. Timing was critical. If turf dried too much, it lost its structural integrity. If it stayed too wet, it rotted. Once prepared, turf was transported to the building site. For roofs, a base layer of birch bark or thin wooden planks was laid over the roof framing. This created a smooth surface and prevented the turf from sagging between the structural beams. Turf blocks were then laid in overlapping rows, grass side up, starting at the eaves and working toward the ridge. Each row overlapped the one below it, like shingles. This overlap prevented water from seeping between the blocks and ensured that rain ran down the roof surface rather than penetrating it. The weight of the turf pressed it together over the time, compacting the soil and creating a dense, continuous layer. Grass continued to grow on the roof. Roots extended downward, knitting the blocks together and anchoring them to the underlying structure. In summer, the roof bloomed with wildflowers. In winter, snow covered it, adding another layer of insulation. The grass needed occasional trimming to prevent it from becoming too tall and heavy, but otherwise the roof maintained itself. Turf roofs provided exceptional insulation. Soil is a poor conductor of heat. A roof half a metre thick effectively trapped warmth inside the building while blocking cold from above. The mass of the turf also stabilised temperature fluctuations. During the day, it absorbed heat from the interior, and at night it released that heat slowly, moderating the drop in temperature after the fire was banked. Walls also incorporated turf. In stone and turf construction, the lower portion of the wall was built from stacked stones, creating a stable foundation. Above this, turf blocks were layered, forming the upper wall. The turf was stacked in courses, each layer set slightly inward from the one below, creating a gently sloping profile. This prevented the wall from collapsing outward under its own weight. Some longhouses were built almost entirely from turf. In treeless regions, where wood was scarce and stone difficult to work, communities constructed buildings using turf for walls, roof, and even internal partitions. These structures were low and rounded, blending into the landscape. They were cooler in summer and remarkably warm in winter, the thick earthen shell providing continuous insulation. Maintenance was required. Turf roofs could develop weak spots where grass died or soil eroded. These areas needed patching with fresh turf before water penetrated to the interior. Walls sometimes settled unevenly, creating cracks that allowed drafts. Repairs were straightforward. Additional turf was cut, shaped, and pressed into place, blending seamlessly with the existing material. The longevity of turf structures varied. A well-maintained turf roof could last decades. A neglected one might fail within a few years. The difference lay in vigilance, catching small problems before they became large ones, keeping vegetation healthy, ensuring drainage worked correctly. Turf also had limitations. It absorbed water. In prolonged rain or during spring thaw, turf could become saturated, increasing its weight and reducing its insulating properties. Proper drainage channels around the building prevented water from pooling near walls and seeping into the structure. Inside, moisture from cooking, breathing, and the presence of animals needed to be managed carefully to prevent condensation from soaking the interior surface of turf walls. Despite these challenges, turf remained the material of choice across much of Scandinavia. It was abundant, renewable, and required no advanced tools to work. A family could cut, transport, and install turf with basic equipment and their own labour. The material cost nothing but effort. Using turf connected the structure to the landscape in a literal way. The building was made from the ground it stood on. When a longhouse was eventually abandoned, the turf decomposed, returning nutrients to the soil. The grass that had grown on the roof seeded the ground around the site. Within a few seasons, the site would be covered in vegetation again, as if the building had never existed. This was not philosophy, it was practicality. But it created a relationship between people and place that was direct and immediate. The land provided shelter. Shelter returned to the land. The cycle continued, generation after generation. Fire was continuous. The hearth in a Viking longhouse was not lit occasionally. It burned all winter, day and night, a constant presence. Letting it die meant starting over from nothing, a process that consumed time, effort, and resources. Keeping it alive was easier, and reliability mattered more than efficiency. The hearth itself was a long, shallow trench or a raised platform of stones running down the centre of the longhouse. In some structures, it extended for 10 metres or more. In others, it was shorter, concentrated in the middle of the building. The length depended on the size of the household and the number of people who needed warmth. Stones lined the hearth on all sides. These were not decorative. They contained the fire, preventing embers from spreading across the earthen floor. They also absorbed and radiated heat. During the day, as the fire burned actively, the stones warmed. At night, when the flames were reduced to coals, the stones continued releasing heat for hours. The type of stone mattered. Some stones, when heated repeatedly, cracked or exploded. Others held heat poorly. Communities learned which local stones were suitable, usually dense, fine-grained types that could withstand thermal stress. These were collected from riverbeds, quarries, or cleared fields and positioned carefully around the hearth. The fire burned wood primarily, though peat, dried seaweed, or animal dung supplemented fuel in regions where wood was limited. Each material burned differently. Wood produced steady flames and relatively little ash. Peat burned slower, with a distinctive earthy smell and more smoke. Animal dung burned quickly, with high heat but copious smoke. The choice of fuel shaped the daily rhythm of fire management. Wood was stacked near the hearth, within easy reach. Logs were split into manageable sizes, not too large to handle, not so small they burned too quickly. Kindling, small sticks, wood shavings, dry bark, was kept in a basket or sack, always ready. Maintaining the fire required constant small additions of fuel, not periodic large loads. This kept the temperature steady and prevented the interior from swinging between too hot and too cold. Tending the fire was shared work. During the day, anyone nearby could add wood when the flames diminished. At night, responsibility rotated. Someone always woke periodically to check the fire, add fuel if needed, and ensure it had not burned down too far. This was not a formal watch but an ingrained habit, learned in childhood and maintained through adulthood. The fire's position in the centre of the building was deliberate. Heat radiated outward in all directions, reaching both long walls equally. If the hearth had been placed against one wall, that side of the building would have been warm while the opposite side remained cold. The central location balanced the distribution, making the entire interior livable. Smoke rose from the fire and drifted upward. Without a chimney, it filled the upper portion of the longhouse before gradually escaping through roof vents. The interior was perpetually hazy. Smoke stung the eyes and irritated the throat, especially when the fire burned damp wood or when wind conditions prevented proper venting. Over time, occupants grew accustomed to it. They learned to keep their heads below the worst of the smoke, to move slowly to avoid stirring it, to breathe shallowly when necessary. The smoke also had benefits. It preserved meat and fish hung from the rafters. It discouraged insects. It treated the wooden beams and roof structure, hardening the wood and making it resistant to rot. The smell of smoke permeated everything: clothing, hair, skin, stored grain. It was the smell of home. Cooking happened at the hearth. Iron pots hung from chains attached to overhead beams, positioned over the hottest part of the fire. Stews simmered for hours, their contents shifting as ingredients were added throughout the day. Flatbreads were baked on hot stones at the fire's edge. Meat was roasted on spits or laid directly on embers. The hearth was also a social centre. People gathered near it not just for warmth, but for light, for company, for the tasks that required seeing clearly. Clothing was mended, tools were repaired, stories were told, children played. The fire defined the space, creating a boundary between the warm, illuminated core of the longhouse and the cold, dark periphery. At night, the hearth determined sleeping arrangements. The elderly and the very young slept closest to the fire, on the raised platforms lining the walls. Adults slept farther away, where the temperature was lower but still tolerable. Positioning was adjusted based on the season, the strength of the fire, and individual tolerance for heat or cold. Banked embers were the key to continuity. Before sleep, the fire was not extinguished but reduced. Large logs were placed on the coals, then covered with a layer of ash. This ash insulated the coals, slowing their burn and preventing flames from rising. The wood beneath continued to smoulder, releasing heat without consuming itself quickly. In the morning, the ash was brushed aside, revealing glowing embers. Fresh kindling was added, air was blown across the coals, and flames returned within moments. This process was reliable but not foolproof. If the fire was banked incorrectly, too much ash, too little wood, the coals could die overnight. Restarting from nothing required either striking sparks with flint and steel onto tinder, or borrowing embers from a neighbouring household. Both options were time-consuming and inconvenient. The skill of banking a fire so it lasted through the night was learned early, and practiced constantly. The hearth burned through winter without interruption. It was the heart of the longhouse in a literal sense. Warm, constant, essential. When spring arrived and the cold finally broke, the fire was allowed to die down. The hearth was cleaned, stones were inspected for damage, and ash was carried outside. The longhouse smelled different without the smoke. It felt different without the heat. But by then the fire had done its work. The household had survived another winter. The work of staying warm began in summer. When the days were long and the air mild, communities moved through the forests and fields collecting the material that would keep them alive 6 months later. This was not optional work. It was survival, measured in careful accumulation. Wood gathering followed a rhythm tied to the landscape. Fallen trees were preferred over cutting live ones. A tree that had died naturally and seasoned for a year or two burned cleaner and hotter than freshly cut timber. Villagers walked familiar routes through the forest, noting where windstorms had brought down branches, where old trees had collapsed, where dead wood leaned against living trunks. The wood was evaluated before being hauled back. Rotten wood was left behind. It produced more smoke than heat and crumbled into useless ash. Wood that was too green, still heavy with sap, was marked and we left to dry for another season. The best fuel was dead wood that had dried naturally, light enough to carry but dense enough to burn slowly. Transport required coordination. A single log too heavy for one person needed 2 or 3. Longer distances meant multiple trips or the use of sleds, even in summer, dragged across grass and dirt. Children carried smaller branches, learning the difference between good kindling and poor. Women bundled sticks with rope or strips of hide, creating loads that could be balanced on the back or shoulder. Splitting wood happened throughout the warmer months. Logs were stood upright on a flat stone or stump, and wedges were driven into them with wooden mallets. The wood split along its grain, falling into halves or quarters. These pieces were split again, reducing them to sizes that could be fed easily into the hearth. Splitting exposed the interior of the wood to air, accelerating the drying process. Stacking was deliberate. Wood was piled under overhangs, against south-facing walls, anywhere it would receive sun and air but remain protected from rain. The stacks were built with space between the pieces, allowing air to circulate. Damp wood rotted, dry wood lasted. The difference determined whether fuel supplies reached the end of winter or ran out weeks too early. In regions where forests were distant or sparse, peat replaced wood as the primary fuel. Peat extraction required different tools and a knowledge. The work began in late spring, when the surface of the bog had dried enough to support weight, but the underlying layers remained moist enough to cut cleanly. A peat spade, a narrow flat blade with a sharp edge, was driven horizontally into the bog wall. Each cut removed a rectangular block roughly the size of a brick. These blocks were heavy, saturated with water. They were laid out on dry ground in rows, turned periodically to expose all sides to sun and wind. Drying peat took weeks. In poor weather, it took months. The blocks shrank as moisture evaporated, becoming lighter and harder. Fully dried peat was brittle, almost powdery on the surface, but dense inside. It burned with a low, steady heat and a distinctive smell, earthy, slightly sweet, unmistakably different from wood smoke. Storing peat required protection from moisture. Even fully dried peat absorbed water quickly if left exposed to rain. Communities built low sheds or covered stacks with hides and woven mats. The peat was stacked loosely at first, then compressed as the pile grew, minimizing air gaps and reducing the space needed for storage. In coastal areas, driftwood supplemented other fuel sources. Wood carried by ocean currents and deposited on beaches was collected after storms. Driftwood was often waterlogged initially and needed extensive drying. Salt from seawater remained in the wood, causing it to burn with different colours in the flame, blue and green, occasionally purple. The salt also made the fire spit and crackle, releasing small bursts of sparks. Animal dung, particularly from cattle, was dried and burned in regions where both wood and peat were scarce. Fresh dung was shaped into flat cakes and pressed against walls or rocks to dry in the sun. Once hardened, these cakes burned quickly, producing high heat but significant smoke and odour. They were used sparingly, often mixed with other fuels to extend supplies. Communities calculated their needs based on experience. A household of 6 required a certain volume of fuel to survive winter. A household of 12 required nearly twice that, though not exactly. Larger households shared a single hearth, gaining some efficiency. Elders could estimate fuel needs by eye, walking past a woodpile and knowing whether it would suffice. Running out of fuel before spring was catastrophic. Families in that situation faced a choice: burn furniture, structural timbers from the house itself, or seek help from neighbours. Neighbours shared if they could, but their own supplies were finite. A household that consistently failed to gather enough fuel became a burden on the community, a problem that affected everyone. Storage space limited how much could be gathered. Fuel needed to be accessible throughout winter, but could not occupy space needed for people, animals, or food stores. Some households built separate storage sheds. Others stacked wood against exterior walls, creating an additional layer of insulation while keeping fuel dry and within reach. The fuel supply was monitored continuously. As winter progressed, the woodpile shrank. Watching it diminish was a source of anxiety. A household that burned through its stores too quickly faced a decision: reduce the fire's intensity, endure colder temperatures, and hope the remaining fuel lasted, or maintain the fire and gamble that winter would end before the wood did. Rationing was common. On milder days, the fire was allowed to burn lower. On the coldest nights, more fuel was added. This constant adjustment required judgment. Miscalculation in either direction had consequences. Too little fire and people suffered. Too much fire and supplies ran out. By the time spring arrived, the woodpile was depleted. What remained was often the poorest quality material. Logs that were too knotted to split easily, wood that had been cut green and never fully dried, scraps saved from other projects. This remnant fuel was burned in the final weeks, supplemented by anything else combustible. The relief when warmer weather returned was tangible. The hearth could finally rest. But even as one winter ended, the next was already anticipated. The cycle began again immediately. Fallen branches from spring storms were collected. Dead trees were noted. The work of gathering fuel never truly stopped. It simply shifted in intensity, a constant background rhythm that shaped the entire year. Every door was a problem. Opening a door in winter allowed cold air to rush in and warm air to escape. The longer the door remained open, the greater the loss. But doors could not be eliminated. People needed to enter and exit. Animals needed access. Supplies needed to be moved. The solution was not to avoid openings, but to control them. The simplest method was a vestibule. Instead of a single door leading directly into the main living space, a small chamber was built at the entrance. This chamber had two doors, an outer door facing the elements and an inner door leading to the interior. The space between them buffered the temperature. When someone entered from outside, they opened the outer door and stepped into the vestibule. Cold air followed them in, but only into this small space. They closed the outer door before opening the inner door. This meant the main interior was never directly exposed to the outside. The cold air that entered remained trapped in the vestibule, slowly warming before it mixed with the interior air. The vestibule was unheated. It was colder than the main longhouse, but warmer than the exterior. This intermediate temperature reduced the shock to the system when moving between zones. It also provided a space to remove snow-covered clothing and leave wet boots before entering the living area, preventing moisture from being trapped inside. Some entrances used angled passages instead of a simple vestibule. The doorway led into a corridor that turned at a right angle before reaching the main interior. This prevented wind from blowing directly into the hearth area. Wind forced to turn a corner lost momentum and velocity. What entered the longhouse was no longer a gust, but a slower, more diffuse flow of air. Low doorways contributed to heat retention. Most longhouse entrances required occupants to stoop or crouch. This was not accidental. A low opening reduced the volume of air that could pass through when the door was open. It also took advantage of thermal stratification. Warm air rose to the top of the interior space while cold air settled near the floor. A low door meant that the warmest air near the ceiling was less likely to escape. Heavy curtains hung over doorways added another layer of control. Even when the physical door was open, the curtain remained in place, draped from ceiling to floor. These curtains were made from thick wool, layered hides or woven reeds, materials that blocked air flow while still allowing passage. Someone entering simply pushed through the fabric. The curtain fell back into place immediately, minimizing the time the opening was exposed. Door construction itself mattered. Doors were thick, often built from multiple layers of wood. Gaps between the door and the frame were sealed with leather strips, wool or packed moss. A poorly fitting door leaked cold air continuously, even when closed. A well-fitted door sealed tightly, preventing drafts. Some longhouses had multiple entrances, each used for different purposes. One entrance, typically on the more sheltered side of the building, was for people. Another, often larger, was for animals or for moving large items like barrels or fuel supplies. Having separate doors reduced the frequency with which any single door was opened, limiting heat loss. The outer door often faced away from prevailing winds. Communities knew which direction winter storms arrived from. Doors were positioned on the opposite side of the building when possible. This meant that wind did not blow directly against the entrance, forcing the door open or pushing cold air through any gaps. In the most exposed locations, short tunnels were built. These extended outward from the main structure, creating a covered passage several meters long. The tunnel walls were built from turf or stone, and the roof was low and heavily insulated. Walking through the tunnel meant moving through a gradual transition zone between outside and inside. These tunnels were dark, narrow, and inconvenient. But they worked. By the time someone reached the inner door, they had already warmed slightly from being out of the wind. The cold air they brought with them had time to settle and dissipate before mixing with the main living area. Doors were opened as infrequently as possible. Tasks that required going outside were grouped together. If someone needed to collect water, check on animals, and retrieve firewood, they did all three in one trip, rather than making 3 separate trips. This reduced the number of times the door opened and closed, preserving interior warmth. At night, doors were secured not just against intruders but against drafts. Wooden bars slid into brackets, holding the door firmly shut. Additional ceiling, extra hides, wadded cloth was pressed into any gaps. The goal was to make the longhouse as airtight as possible during the coldest hours. Even with all these measures, some heat loss was inevitable, but the architecture minimized it. What could have been a catastrophic drain on warmth became manageable. The difference between a well-designed entrance and a poorly designed one was measurable. Several degrees of interior temperature sustained over months. Communities that built without attention to entrance design suffered for it. Longhouses with single, exposed doors required larger fires to maintain the same interior temperature. They burned through fuel faster. They were less comfortable. Over time, these structures were modified. Vestibules added, passages angled, curtains hung. The architecture adapted, guided by the simple feedback of cold air and wasted warmth. The entrance was not glamorous. It was not the hearth with its fire and light. It was not the roof visible from outside, but it was critical. A good entrance allowed the longhouse to function as a sealed environment, trapping warmth and and moderating temperature. A poor entrance undermined everything else. The Vikings understood this. They built accordingly. Sleep happened above the floor. The coldest air in any room settles at the lowest point. This is not opinion, it is physics. Cold air is denser than warm air. It sinks, pooling in hollows, collecting near surfaces, pressing down against the ground. In a Viking longhouse, the floor was the coldest place to be. Sleeping platforms solved this problem. These were raised structures built along both long walls of the longhouse, running nearly the entire length of the interior. They were constructed from wooden planks laid across horizontal supports, creating a surface roughly half a metre above the floor. This elevation was enough to lift sleepers out of the coldest air layer. The space beneath the platforms was not wasted. It became storage. Barrels of grain, sacks of dried fish, baskets of root vegetables, tools, animal feed. This storage was accessible but out of the way, leaving the main floor clear for movement and daily tasks. The items stored below also provided a small amount of additional insulation, creating a barrier between the cold floor and the sleeping surface above. The platform surface itself was covered. Bare wood was uncomfortable and drew heat away from the body. Layers of insulation were added. Woven mats, animal hides, wool blankets, stuffed sacks filled with straw or dry grass. These layers trapped air, creating pockets of insulation between the sleeper and the wood. Furs were particularly effective. Sheepskin, reindeer hide, bear pelts, each had different properties. Sheepskin was common, readily available, and provided good insulation without excessive weight. Reindeer hide was lightweight and warm. the hollow structure of reindeer hair trapping air effectively. Bear pelts were heavy, extremely warm, and often reserved for the elderly or the sick. Families slept together. In a longhouse with multiple generations, the arrangement followed a pattern. The elderly and the very young occupied positions closest to the central hearth. These individuals generated less body heat and were more vulnerable to cold. Adults slept farther from the fire, where temperatures were lower but still tolerable. Sleeping arrangements were practical, not sentimental. Warmth was shared, bodies pressed together under shared coverings, pooling heat. This was especially true for children, who often slept in clusters. An adult sleeping alone lost heat to the surrounding air. A group sleeping together created a microclimate, warmer than the ambient temperature. Heat from the hearth rose, spreading toward the ceiling, before gradually sinking as it cooled. The sleeping platforms intercepted this rising warmth. Someone lying on the platform was positioned directly in the path of heated air moving upward from the fire. This passive positioning required no effort but made a measurable difference in comfort. The platforms also provided psychological separation. The floor was a work surface, a place for activity, for animals, for mess. The platform was a rest surface, a place set apart. This distinction helped regulate the household's rhythm. Activity happened below, rest happened above. Lighting was minimal at night. The hearth provided a faint glow from banked embers, but it was too dim to navigate by. People moved to their sleeping spots before full darkness, settling in while some light remained. Once positioned, they stayed put. Moving in the dark risked tripping, knocking over stored items or disturbing others. Condensation was a concern. Warm breath and body heat produced moisture. In a cold environment, this moisture condensed on the coldest surfaces. Walls, roof timbers, anything near the exterior. Sleeping too close to an exterior wall meant waking to dampness. Platforms positioned slightly inward from the walls avoided this problem. Ventilation was limited at night. Roof vents were partially closed to retain heat, and doors were sealed. This meant the interior air became stale, thick with smoke from the hearth, moisture from breathing, odours from people and animals. It was unpleasant but tolerable. Fresh air was a luxury reserved for warmer months. The position on the platform also reflected status and need. The household head and their partner typically slept in the most desirable spot, closest to the hearth but not so close as to be uncomfortably hot. This position balanced warmth with comfort. Those sleeping at the far ends of the longhouse away from the fire experienced noticeably colder temperatures. Adjustments were made throughout the night. If someone became too cold, they moved closer to the fire or pulled additional coverings over themselves. If someone became too warm, they shifted position, moved a layer aside, or repositioned to allow air circulation. These adjustments happened instinctively, without fully waking. Children sometimes woke during the night and moved. A child who had fallen asleep at the edge of the platform might migrate toward the centre, seeking the warmth of others. This was accepted. No one was scolded for seeking comfort. Survival depended on everyone staying warm enough to function the next day. Illness changed the arrangement. Someone sick was moved closer to the hearth, given additional coverings, attended more carefully. Fever was dangerous, but so was cold. Balancing. The two required observation and adjustment. Elderly individuals nearing the end of their lives often spent entire days and nights on the platform, rising only when necessary. Platforms wore over time. The wooden planks developed grooves where bodies had lain year after year. These depressions became familiar, almost personalized. Each family member knew their spot where the wood dipped, where the edge was slightly higher, where the support beam created a subtle rise. When morning came, people rose slowly. The hearth was tended first, embers uncovered, kindling added, flames coaxed back to life. The interior warmed gradually. Only then did the household fully leave the platforms, descending to the floor to begin the day's work. The platform was simple. It required no advanced engineering, no rare materials, just wood, elevation, and an understanding of how heat moved through space. But it worked. It kept people off the cold floor, positioned them in rising warmth, and allowed sleep to happen even in the depths of winter. That simplicity was its strength. Stone held heat differently than wood or air. When a stone was placed near a fire, it did not warm quickly. The heat penetrated slowly, moving into the stone's mass centimetre by centimetre. This gradual absorption meant that a stone near a fire in the morning might not reach its peak temperature until afternoon. But once heated, the stone released that warmth just as slowly. This property made stone invaluable in winter. A fire burned actively during the day, when people were awake and moving, when tasks required light and heat. At night, the fire was reduced to conserve fuel. Flames died down to glowing coals, the air began to cool, but stones placed around the hearth continued radiating warmth for hours after the active burning stopped. The Vikings understood this and positioned stones accordingly. Large stones were set directly into the hearth structure, forming the sides and base of the fire pit. Smaller stones were placed close to the flames, in rings around the active burning area. These stones absorbed heat continuously throughout the day. Not all stones were suitable. Porous stones, or those containing moisture, could crack or explode when heated rapidly. The expansion of trapped water created pressure inside the stone, and the stone shattered, sending fragments across the interior. This was dangerous. It could injure someone nearby, scatter embers outside the hearth, or damage stored goods. Communities learned which stones worked. Dense, fine-grained stones from riverbeds were reliable. Granite and basalt held heat well and resisted cracking. Limestone was softer but acceptable if heated gradually. Sandstone was avoided. It crumbled under repeated heating and cooling cycles. The stones were not moved frequently. Once positioned around the hearth, they remained in place for years. Over time, they blackened from smoke and absorbed oils from cooking. Their surfaces became smooth, polished by the passage of heat and the occasional contact with tools or hands reaching near the fire. During the day, the stones were part of the cooking process. Flat stones were used as baking surfaces for flatbreads. Heated stones were dropped into wooden containers filled with water, bringing the water to a boil without exposing the container to direct flame. Meat was roasted by placing it on or against hot stones, the even heat cooking it slowly and thoroughly. But the stone's most important role came at night. As the household settled onto the sleeping platforms and the fire was banked, the stones continued their work. They radiated infrared heat, a gentle, penetrating warmth that moved through the air without flames or light. This radiant heat kept the interior temperature from dropping as quickly as it would have otherwise. The effect was subtle but significant. In a longhouse without heated stones, the interior temperature might drop 10 degrees within a few hours of banking the fire. With stones, the drop was slower, perhaps half that amount over the same period. This difference meant the household woke to a cold interior instead of a freezing one, making the morning routine more bearable. Some households used portable heated stones. These were smaller rocks that could be lifted with tongs or wrapped in cloth. A heated stone placed at the foot of a sleeping platform provided localized warmth. Someone ill or elderly might sleep with a wrapped heated stone against their body, a personal source of warmth that lasted through the night. Heating these portable stones required planning. They needed to be positioned near the fire in the late afternoon, giving them time to absorb heat before being moved. If placed too close to the flames, they became too hot to handle safely. If placed too far away, they did not heat sufficiently. Experience taught the right distance and timing. Children sometimes burned themselves on stones that appeared cool but retained heat internally. The surface of a stone could feel warm but tolerable while the interior remained much hotter. Pressing a hand against such a stone for more than a moment caused burns. This risk was managed through caution, and the same lessons repeated to each generation. Stones also helped stabilize the fire itself. The thermal mass around the hearth absorbed excess heat during periods of high burning, preventing the interior from becoming uncomfortably hot. When the fire died down, that stored heat was released, moderating the temperature swing. The longhouse interior remained more thermally stable than it would have without this mass. Over seasons, stones degraded. Repeated heating and cooling created microscopic cracks. Surface layers flaked away. Eventually, a stone that had been reliable for years would split during heating, or crumble when moved. These failed stones were replaced, tossed outside the longhouse, and new stones were brought in to take their place. The accumulation of broken stones around longhouse sites created distinctive archaeological evidence. Excavations centuries later revealed concentrations of fire-cracked rock, layers of blackened stone fragments mixed with ash and charcoal. These deposits told a story of sustained use, of fires maintained year after year, of stones heated until they failed and were discarded. The knowledge of stone use was not written, it was observed. Children grew up watching adults select stones, position them, adjust them as needed. They learned by seeing which stones cracked and which endured. They absorbed the timing when to place a stone near the fire, when to move it, when to wrap it for transport. This knowledge was practical and specific. It did not transfer well to new environments with different geology. A family moving to a new region had to relearn which local stones were suitable. The principles remained the same, but the application required fresh observation and experimentation. Stones were ordinary, they were free, abundant, and required no processing beyond cleaning and positioning. Yet their contribution to winter survival was substantial. They extended the effective heating period of each fire, reduced fuel consumption, and provided a thermal buffer that made the long nights more survivable. The Vikings did not invent the use of heated stones. Many cultures understood this principle, but they integrated it thoroughly into their domestic architecture. The hearth and its surrounding stones functioned as a system, each element enhancing the other. The result was warmth that persisted long after the flames had faded. The longhouse was not only for people. Cattle, sheep, goats, pigs, these animals moved indoors when winter arrived. They did not live in separate barns at a distance from human habitation. They lived under the same roof, sometimes in the same room, sharing warmth and space with the household. This arrangement was practical. Animals generated body heat continuously. A cow at rest produced roughly the same heat output as several adult humans. A cluster of sheep huddled together created a warm zone that extended beyond their immediate position. This heat was not wasted. It rose into the shared interior space, contributing to the overall temperature. The layout of the longhouse accommodated this cohabitation. In some structures, animals occupied one end of the building while people occupied the other. A partition, sometimes a solid wall, sometimes just a low barrier, separated the two zones. In other longhouses, animals were housed in a lower section or a side room, with the floor sloped to allow waste to drain away from the living area. The number of animals housed indoors depended on the size of the building and the wealth of the household. A wealthy family might bring in a dozen cattle, along with smaller animals. A poorer household might have only a few sheep and a pig, but nearly every household brought some animals inside. The practice was universal across Scandinavia during winter months. Cattle required the most space. They were large and they needed room to stand, lie down, and move slightly. Confining them too tightly caused stress, reduced their health, and made them difficult to manage. But giving them too much space wasted interior volume that could have been used for people or storage. The balance was judged by experience. Sheep were easier to house. They tolerated crowding better than cattle and required less vertical clearance. A flock could be packed into a relatively small area, their thick wool providing insulation not just for themselves but for the space they occupied. The smell was strong, a mixture of lanolin, damp wool and manure, but it was tolerable. Goats were more active. They climbed, chewed and explored. Keeping them contained required more attention, but goats were hardy, requiring less feed than cattle, and producing milk through much of the winter. For households that could manage them, goats were a valuable addition to the indoor population. Pigs were kept in smaller numbers. They generated significant heat and could digest food scraps that other animals could not, but they were messy and destructive if not properly confined. Some households kept pigs in a separate small structure attached to the main longhouse, allowing heat transfer without direct cohabitation. Feeding animals indoors required planning. Hay, dried grass, stored grain, and root vegetables were distributed daily. The amount needed was substantial. A single cow consumed roughly 10 kilograms of hay per day. A household with multiple cattle required several tons of fodder to last through winter. This fodder was stored in lofts above the animal area or in covered pits outside, brought in as needed. Manure accumulated. Animals produced waste continuously, and it could not simply be left to pile up. Floors in animal areas were covered with straw, reeds, or dried grasses that absorbed moisture and contained the waste. This bedding was replaced periodically, sometimes weekly, sometimes less often if materials were scarce. The soiled bedding was tossed outside, where it froze and was left until spring. The smell was constant. There was no avoiding it. Humans living in close proximity to animals adapted to the odour, their senses dulling over time. Visitors from outside often found the smell overwhelming, but residents barely noticed. It became part of the background, like the smoke from the hearth. Moisture was a greater problem than smell. Animals exhaled water vapour, and their bodies released heat-laden moisture. This moisture condensed on cold surfaces, walls, roof timbers, stored goods. Excessive moisture led to rot, mould and deterioration of materials. Managing this required ventilation even in winter, allowing some air exchange to carry moisture out before it caused damage. The animals' presence affected the social dynamics of the household. Their sounds, lowing, bleating, snuffling, were continuous. They moved during the night, shifting position, occasionally knocking against barriers. Milking, feeding and cleaning required labour that was added to the daily routine, but the trade-offs were accepted. The warmth they provided was measurable and necessary. Calving, lambing or other births sometimes occurred during winter. This was risky. Newborns were vulnerable to cold and the mother required extra care and feed. But successful births increased the household's wealth and ensured future productivity. The newborns were kept closest to the human living area, where temperatures were highest and observation was easiest. Animal health directly affected human survival. Sick animals did not produce milk, did not generate as much heat, and represented a loss of valuable resources. Households monitored their animals closely, noting changes in behaviour, appetite or appearance. Simple remedies, adjusting feed, providing extra bedding, isolating a sick individual, were applied based on accumulated knowledge. When spring arrived, animals were moved back outside. They were thinner, their coats matted, their hooves overgrown from months without natural wear. But they had survived. The household had survived. The symbiotic relationship had worked once again. The practice of housing animals indoors was not unique to Vikings. Many cold climate cultures followed similar patterns. What varied was the degree of integration. Some cultures built entirely separate heated structures for animals. The Vikings integrated them into the primary dwelling, maximising the transfer of heat and minimising the number of structures that needed to be built and maintained. This integration required cultural acceptance. The idea of living in the same enclosed space as large animals was not inherently obvious or comfortable. It required a shift in perspective, seeing animals not just as property or food sources, but as contributors to the household's thermal budget. That shift happened gradually, over generations, driven by the simple reality that it worked. The longhouse in winter was a shared space, humans at one end, animals at the other, both contributing to and benefiting from the collective warmth. The boundaries between species blurred in practical terms. Everyone breathed the same smoky air, endured the same cold and waited together for spring. Villages were not scattered randomly across the landscape. Buildings stood close together, their walls nearly touching in some places. This clustering was not accidental. It was a response to wind, to heat loss, and to the simple physics of how cold moves through space. Wind removes heat from any surface it touches. A building standing alone on open ground loses warmth continuously as wind flows over and around it. The moving air strips heat from the walls, the roof, every exposed surface. The colder the wind and the faster it moves, the greater the loss. When buildings are placed close together, they shelter each other. A longhouse positioned behind another breaks the wind before it reaches the second structure. The wind loses velocity, its ability to remove heat diminishes, and the shelter building retains more warmth with less effort. This effect multiplied across an entire village. Buildings arranged in clusters created zones of reduced wind. The outer structures bore the brunt of the weather, while those in the interior existed in a calmer microclimate. The temperature difference was measurable, several degrees warmer into the protected centre compared to the exposed edges. The spaces between buildings mattered. Too much distance and the sheltering effect disappeared. Too little and other problems emerged. Fire risk, difficulty moving between structures, inadequate drainage. The optimal spacing was close enough that wind could not accelerate between buildings, but far enough that people and animals could pass through comfortably. Some villages arranged buildings in rough circles or ovals, creating a central courtyard. This layout provided maximum wind protection for the interior space. Storm winds, no matter which direction they came from, encountered buildings first and lost energy before reaching the centre. The courtyard became a relatively calm zone used for work that could not be done indoors. Shared walls were rare but not unknown. In the most densely built settlements, some structures shared a common wall, reducing the number of exposed surfaces. A shared wall was warmer than two separate walls with space between them. Heat loss through the wall affected both buildings equally, but the total heat lost to the environment was less than if both buildings had stood alone. The orientation of buildings within the cluster also mattered. Longhouses, with their long axis aligned perpendicular to prevailing winds, presented a smaller profile to the weather. Those aligned parallel faced greater wind pressure along their entire length. Villages positioned buildings to minimize this exposure whenever terrain allowed. Pathways between buildings were deliberately narrow. Wide paths allowed wind to channel through, accelerating as it was funneled between structures. Narrow paths disrupted this flow, forcing wind to slow or move around obstacles. In winter, these paths were often covered with temporary roofing. Highs stretched between buildings, creating semi-enclosed corridors that protected movement between structures. Snow accumulation contributed to insulation. When snow piled against the exterior walls of buildings, it created an additional insulating layer. Snow is mostly trapped air, and air is an excellent insulator. A thick snowbank against a wall reduced heat loss through that section of the structure. Some communities actively piled snow against walls, sculpting it into place to maximize this effect. The proximity of buildings also facilitated resource sharing. Households that ran low on fuel could borrow from neighbours without venturing far into the storm. Tools, food and labour were exchanged more easily when buildings stood close together. In emergencies, a structural failure, a medical crisis, a fire that needed to be contained, help was immediately available. But proximity also concentrated risks. Fire in one building threatened all nearby structures. Smoke from multiple hearths mixed together, creating a haze over the entire village. Disease spread more easily when people lived in close quarters. These risks were understood and accepted. The benefits of clustering outweighed the dangers. Thermal mapping of the village would have shown distinct patterns. The outer buildings were coldest, their exterior walls exposed to full wind and weather. The inner buildings were warmest, sheltered on multiple sides. The gradient was gradual but real. Households on the edge required more fuel to maintain the same interior temperature as those in the centre. This disparity shaped social dynamics. Wealthier or more influential families sometimes occupied central positions, benefiting from the shelter provided by surrounding structures. Newer or lower status households built on the periphery, accepting greater exposure as part of their position in the community. Over time, as households grew or declined, positions might shift, but the pattern persisted. Animal pens and storage structures were positioned strategically. Pens for animals not housed inside the longhouse were placed on the windward side of the settlement when possible, creating an additional barrier against incoming cold. Storage sheds were positioned close to longhouses, minimizing the distance fuel or food needed to be carried through weather. The village itself generated a collective thermal signature. Multiple hearths burning simultaneously released heat into the air above the settlement. On calm nights, this warmth created a slightly elevated temperature zone over the village compared to the surrounding open land. The effect was minor but detectable, perhaps 1 or 2 degrees difference. Communities that built without attention to proximity paid for it. Isolated farmsteads, where a single household lived far from others, faced winter alone. They had no wind shelter except what the terrain provided naturally. They could not share resources or labour. Their fuel consumption was higher, their risks greater, their margin for error smaller. Over generations, the optimal patterns of village layout were refined. Successful settlements were studied and imitated. Unsuccessful ones, those that lost too many people to cold, fire or resource depletion, were remembered as cautionary examples. The knowledge of how to arrange buildings for mutual protection became part of the cultural inheritance, passed along with other survival skills. The village was more than a collection of individual homes. It was a system, each building contributing to and benefiting from the collective arrangement. The whole was warmer than the sum of its parts, a physical manifestation of the cooperation required to survive Nordic winter. Fire that died overnight was a failure. Restarting a fire from nothing took time, effort and materials. It required striking sparks from flint and steel onto prepared tinder, coaxing those sparks into flame and building the flame into a sustainable fire. In cold hands with damp materials, this process could take an hour or more. An hour without heat on a winter morning was unacceptable. The solution was banking, the practice of preserving embers through the night so they could be revived at dawn. This was not a simple task. It required understanding how fire consumed oxygen, how ash insulated, and how wood burned at different rates depending on its size and moisture content. The process began before sleep, as the household settled onto the sleeping platforms. Someone tended the hearth one final time. This was often the eldest adult, the person with the most experience, though the skill was taught to everyone capable of performing it. Large logs were selected from the woodpile. These needed to be dense, dry, and as thick as possible. Oak, if available, was ideal. It burned slowly and produced long-lasting coals. Birch was acceptable. Pine burned too quickly and was avoided for overnight use. The logs were placed on the existing fire, positioned carefully. They were not thrown on haphazardly. The arrangement mattered. Logs placed too loosely allowed too much airflow, causing them to burn faster. Logs placed too tightly smothered each other, preventing ignition. The proper spacing allowed the logs to catch fire gradually, burning from the outside inward. Once the logs were in place and flames had begun to consume them, the banking process started. Wood ash from earlier burning was collected from the edges of the hearth. This ash was cool enough to handle, powdery and light grey. It was spread over the burning logs in a thick layer, covering them completely. The ash served as insulation. It reduced the amount of oxygen reaching the burning wood, slowing the combustion. The logs beneath continued to burn, but at a greatly reduced rate. Instead of flames, the wood smouldered, releasing heat slowly without consuming itself quickly. The goal was to have the wood burn just fast enough to last through the night, but not so fast that it was consumed before morning. The thickness of the ash layer determined the burn rate. Too little ash and the fire burned too hot, exhausting the fuel before dawn. Too much ash and the fire suffocated entirely, the embers dying under the insulating weight. Experience taught the correct amount, usually several centimetres thick, evenly distributed. The banked fire glowed faintly beneath the ash. If someone looked closely, they could see a dull orange light where the ash was thinnest. Heat radiated from the hearth, less intense than during active burning but still present. The stone surrounding the hearth continued releasing, stored heat, supplementing the warmth from the banked coals. Through the night, the fire consumed the logs slowly. The process was invisible beneath the ash layer. The wood converted to charcoal, then to ember, then to ash. The heat output remained relatively constant for hours, declining gradually as the fuel was depleted. Checking the fire during the night was common. Someone would wake, either naturally or because they had assigned themselves the task, and approach the hearth. They would look for the glow beneath the ash, confirming the embers still lived. If the glow seemed weak, a small amount of ash could be carefully removed, allowing more oxygen to reach the coals and reviving them slightly. Adding fuel during the night was possible, but usually unnecessary if the banking had been done correctly. A properly banked fire with sufficient fuel lasted from evening to morning without intervention. Only in the coldest conditions, or if the initial banking had been inadequate, did someone need to add wood during the dark hours. Morning brought the revival process. The first person to rise approached the hearth with a thin stick or a fire poker. They carefully pushed aside the ash covering, exposing the layer beneath. If the banking had succeeded, glowing embers were revealed, hot, orange, ready to be rekindled. Kindling was added immediately. Small dry twigs and wood shavings prepared the previous day. These were placed directly on the exposed embers. Air was blown across the embers, either by mouth or using a bellows if the household possessed one. The increased oxygen caused the embers to brighten and heat intensified. Within moments, the kindling began to smoke, then to smoulder, then to catch flame. Small flames spread through the kindling, growing as they consumed the material. Larger sticks were added, then split logs. Within minutes, the fire was fully revived, flames rising from the hearth as they had the previous day. If the banking had failed, if the embers had died overnight, the household faced the laborious process of starting from scratch. Flint and steel were retrieved, tinder was prepared, fine, dry material such as dried grass, shredded bark, or charred cloth. The steel was struck repeatedly against the flint, creating sparks. These sparks fell onto the tinder, and the person blew gently, encouraging the tinder to glow and eventually flame. This process was so time-consuming and frustrating that it motivated extreme care in banking the fire correctly. A household that frequently let its fire die gained a reputation for carelessness. Children who were learning fire management and failed at banking were not punished harshly, but the lesson was impressed upon them through repetition and observation. Some households maintained a small ember pot as backup. This was a ceramic or metal container filled with sand or ash, with a cavity in the centre where a few live coals were placed. The container was covered, restricting oxygen and preserving the coals for extended periods, sometimes days if needed. This served as insurance against a failed banking, allowing fire to be restarted more easily. Borrowing fire from a neighbour was another option if the hearth died and no ember pot was maintained. Someone would carry a small container, often a broken pot or a hollowed piece of wood, to a neighbour's longhouse, request a few live coals, and transport them back carefully. This was not shameful, but it was inconvenient and acknowledged the household's failure to preserve its own fire. The skill of banking fire was fundamental to winter survival. It saved fuel by preventing the need to build a fire from nothing each morning. It saved time, allowing the household to begin the day's work without delay. It provided psychological comfort. Waking to a revivable fire was waking to the promise of immediate warmth. The practice was taught through observation and participation. Children watched adults bank fires evening after evening. They were eventually allowed to help, adding ash under supervision. As they grew, they took on the responsibility themselves, learning through mistakes how much ash was needed, how to select proper logs, when to check during the night. The knowledge was not written. No manual explained the process. It was embodied, in the feel of ash between fingers, in the judgment of ember brightness, in the practiced motion of uncovering coals at dawn. This knowledge was as essential as knowing which stones held heat, or how to stack turf for insulation. It was part of the accumulated wisdom that kept communities alive through winter. The ceiling of a longhouse was black. Years of smoke had stained the wooden beams and the underside of the roof. The original colour of the wood, pale birch, reddish pine, golden oak, had disappeared under layers of soot and tar. The beams were slick to the touch, coated with a dark residue that never fully dried. This blackening was not damage, it was preservation. The smoke deposited chemicals onto the wood, creosote, pH, and other compounds formed during combustion. These substances penetrated the surface, hardening the wood and making it resistant to rot and insect infestation. A smoke-darkened beam lasted decades longer than untreated wood exposed to the elements. But the beams held more than chemical residue. They held memory. The accumulated experience of every winter the longhouse had endured. Someone entering a longhouse for the first time could read those beams, estimating the building's age by the depth of the blackening, the smoothness of the surface, the patterns of soot distribution. Knowledge passed through observation of these spaces. Children grew up in longhouses, watching adults manage fire, position fuel, bank embers, adjust ventilation. They learned not through formal instruction, but through daily immersion in the rhythms of winter survival. Fire management was learned by proximity. A child sitting near the hearth saw how wood was added, not in large amounts that caused flames to surge and waste heat, but in small frequent additions that kept the burn steady. They saw how different wood types burned differently, how dry wood caught quickly while damp wood smouldered and smoked. They learned by being given small tasks, fetching kindling from the pile, carrying a few sticks to the hearth, watching the fire while an adult stepped away briefly. These tasks were simple but meaningful. They built familiarity with fire's behaviour, its demands, its dangers. Mistakes were part of learning. A child who added too much wood at once saw the fire flare too hot, saw adults react quickly to adjust it, and learned the consequence of excess. A child who added too little saw the fire die down to embers prematurely, saw the effort required to revive it, and learned the consequence of neglect. The household itself was the classroom. Every action related to warmth and survival happened in the shared space of the longhouse. There was no separation between learning and living. Knowledge was not stored in books or explained in lectures. It was demonstrated continuously through the winter months, season after season. Elderly members of the household held the deepest knowledge. They had survived the most winters, had seen the most variations in weather, had managed the most crises. Their judgment was trusted. When they positioned stones around the hearth, selected logs for overnight burning, or decided when to open or close ventilation, others watched and absorbed the reasoning. This knowledge was often unspoken. An elder might bank a fire without saying a word, and younger household members would observe the thickness of the ash layer, the spacing of the logs, the timing of the action. The next night, when that younger person banked the fire, they replicated what they had seen, adjusting based on the feedback of whether the fire survived until morning. Questions were asked, but often the answer was simply watch. The elder performed the task again more slowly, allowing observation of each step. Explanation came through repetition more than through words. The learner built an internal model of the process through repeated exposure. Failure was instructive. When a fire went out overnight, the household discussed what had gone wrong. Was the ash layer too thick? Were the logs too small? Had the wood been too damp? These post-failure analyses built diagnostic skills, teaching people to evaluate their own actions and adjust future attempts. Success was less often discussed, but equally instructive. When a fire was perfectly banked and revived easily in the morning, that outcome was noted. The person who had banked it remembered what they had done, cementing that approach as reliable. The knowledge was also physical. Banking a fire required feeling the heat of the hearth on the face and hands, gauging how hot the logs were before covering them with ash. It required judging the weight of ash in the hand, knowing by feel how much was needed. These tactile dimensions could not be taught through words alone. Generational transfer happened naturally. A mother banking a fire worked alongside her daughter, who eventually took over the task while the mother supervised. A father splitting wood showed his son which grain patterns indicated easy splitting and which meant the log would resist. The transfer was gradual, almost invisible, occurring through thousands of small interactions over years. The Longhouse itself was the repository of this knowledge. The smoke-darkened beams, the worn sleeping platforms, the fire-cracked stones around the hearth, each element carried the evidence of past actions and past decisions. A new generation inherited not just a structure but a living record of how their predecessors had survived. This knowledge was fragile in one sense. It depended on continuity. A break in the chain, a generation lost to disease, a community destroyed by conflict, meant the knowledge had to be rebuilt from first principles or borrowed from neighbours. But in another sense, it was robust. Because it was distributed across entire communities and practiced daily, it was difficult to lose completely. When a household moved to a new location, they carried this knowledge with them. They built a new longhouse using the same principles, positioned stones around a new hearth in familiar patterns, banked their first fire using techniques learned in childhood. The physical structure was new, but the knowledge animating it was old. The smoke-darkened beams of an established longhouse represented decades of accumulated wisdom. They had witnessed countless cycles of preparation, burning, banking, and revival. They had absorbed the heat of thousands of fires. They stood as silent testament to the effectiveness of the methods practiced beneath them. Someone entering such a longhouse in winter, feeling the warmth, seeing the steady fire, noting the efficient layout, was experiencing not just shelter but generations of refined practice. The knowledge was invisible, embedded in every detail, taken for granted by those who possessed it but immediately obvious in its absence. This was how the communities survived, not through individual brilliance or dramatic innovation, but through the patient accumulation and transfer of practical knowledge, passed from one generation to the next, refined through experience, and preserved in the daily rhythms of winter life. Darkness came early and stayed late. In the depths of winter, the sun barely cleared the southern horizon. At the latitude of much of Scandinavia, daylight during the winter solstice lasted for perhaps 4 to 6 hours. The rest of the day existed in twilight or complete darkness. This darkness was not metaphorical. It was physical, measurable, absolute. Without artificial light, the world disappeared. The landscape outside the longhouse became invisible. The interior spaces faded to shadow. Movement became difficult. Work that required seeing could not be done. Fire provided the primary light source. The hearth burned continuously, its flames casting flickering illumination across the interior. This light was unsteady, moving with the flames, creating dancing shadows on the walls and ceiling. It was warm-toned, orange, yellow, occasionally red, and it did not reach far. The corners of the longhouse remained dim even when the fire burned actively. The quality of light changed with the fire's intensity. During active burning, when flames rose high and wood crackled, the interior was relatively bright. Faces were visible, expressions could be read, detailed work could be done near the hearth. When the fire was banked at night, the light diminished to a faint glow, barely enough to navigate by. Oil lamps supplemented the hearth. These were simple devices, shallow stone or ceramic bowls filled with animal fat or fish oil, with a twisted fibre wick floating on the surface. The wick burned slowly, drawing oil up through capillary action and producing a small steady flame. These lamps provided localized light. One lamp illuminated a small area, enough for someone to work on a specific task, but not enough to light an entire room. Multiple lamps could be positioned around the interior, creating islands of light in the darkness. But fuel for lamps was valuable. Excess animal fat and oil were needed for cooking, for treating leather, for waterproofing. Using them for light was a trade-off. The light from oil lamps was different from firelight. It was steadier, less flickering, but also dimmer and more contained. The flame was smaller, producing less smoke but also less warmth. Someone working by the lamplight for an extended period would position themselves near the hearth as well, needing both light and warmth to function comfortably. Candles existed but were rare. Beeswax candles required access to honey production, which was limited in northern climates. Tallow candles made from rendered animal fat were more common, but still represented a significant investment of resources. They were used sparingly, reserved for specific needs rather than general illumination. The darkness shaped daily rhythms. Work that required seeing, mending clothing, tool repair, detailed craftwork, was done during daylight hours or near the hearth, when light was adequate. Work that could be done by feel or memory, tending animals, organizing stores, simple food preparation, could continue in dimmer conditions. Nighttime was for rest, for storytelling, for activities that did not require visual precision. Households gathered near the hearth, sitting close enough to see each other's faces in the firelight. Conversations happened, stories were told, songs were sung. These activities required no light beyond what the fire provided, and they filled the long dark hours. The psychological impact of extended darkness was real. Humans are adapted to cycles of light and dark, and disruption of those cycles affects mood and energy. The short days and long nights of Nordic winter created conditions that favoured rest over activity, conservation over expenditure. This affected behaviour. People slept longer in winter, not because they needed more sleep, but because darkness encouraged it. There was less to do, less light to work by, and the warmth of the sleeping platform was more appealing than the cold darkness beyond the fire's reach. Children struggled more with the darkness. They had more energy, less patience for enforced stillness, and less developed tolerance for the confinement of the longhouse. Managing restless children in a dark, crowded space required patience and creativity. Games were played, tasks were assigned, and stories were told to occupy attention. The contrast between interior and exterior darkness was stark. Outside on a clear night, starlight and moonlight reflected off snow, creating enough illumination to navigate. But clouds blocked this light, and storms brought absolute darkness. On such nights, leaving the longhouse was disorienting and dangerous. People stayed inside unless necessity forced them out. Fire took on symbolic weight in this context. It was not just warmth and light, but a marker of human presence, of safety, of life continuing despite the cold and dark pressing in from all sides. The hearth was the centre not just physically, but psychologically, the point of orientation in an otherwise dark world. Morning light, when it came, was gradual. The darkness did not lift all at once, but faded slowly through shades of grey. The interior of the longhouse brightened incrementally, details emerging from shadow. People did not leap into activity at first light, but rose slowly, adjusting to the return of visibility. This cycle repeated daily through the winter months. Long darkness, brief light, long darkness again. The rhythm became normal, expected. People adapted, their expectations shifting to match the reality of their environment. But the adaptation had limits. Even those who had lived their entire lives in this pattern felt the weight of the long dark. Spring's return, the gradual lengthening of days, the return of sustained sunlight, brought palpable relief. Light was not just practical, it was restorative. Its absence was endured, but its return was welcomed. The longhouse in winter existed in a state of managed dimness. The fire burned, lamps flickered, and people moved through spaces they knew by memory as much as by sight. Light was conserved, rationed, appreciated. It was never taken for granted because it was never abundant. The darkness defined the boundaries of the livable world, and the small pools of light within the longhouse were what made life possible within those boundaries. The wood pile shrank steadily. Every day fuel was carried from the stack outside to the hearth inside. Every night it burned. The pile diminished at a rate that could be calculated, a rough estimate of how many days remained before the supply was exhausted. This calculation was never far from anyone's mind. A household that miscalculated, that gathered too little in autumn or burned too freely in early winter, faced a crisis. Running out of fuel before spring arrived meant cold, hunger, and potentially death. The first response to dwindling supplies was rationing. The fire was kept lower during the day, providing just enough warmth to prevent freezing but not enough for comfort. At night, the banking process used smaller logs, accepting that the interior would be colder by morning in exchange for conserving fuel. Rationing required discipline. It was tempting to burn more when cold to prioritize immediate comfort over future survival. Households that lacked this discipline suffered the consequences. Those who maintained it increased their chances of making it through. Alternative fuels became necessary when wood supplies fell too low. Peat, if available, was used more heavily. It burned with less heat than wood, but was better than nothing. The smell of peat smoke, earthy, slightly sweet, replaced the sharper smell of wood smoke inside the longhouse. Dried seaweed could be burned in coastal areas. It ignited easily, burned quickly, and produced intense heat but copious smoke. The smoke was acrid, irritating to the eyes and throat, but tolerable when the alternative was no fire at all. Seaweed was collected along the shore during milder weather, dried and stored as a backup fuel source. Animal dung, dried cakes of cattle or sheep or horse manure was another option. It burned surprisingly well once fully dried, producing steady heat though with significant smoke and odour. Communities that raised livestock routinely saved dung for this purpose, stacking the dried cakes near the longhouse for use when other fuels ran short. Household items became fuel in desperate situations. Broken tools with wooden handles, worn-out furniture, damaged barrels, anything wood could be burned. This was a last resort. Every piece of wood furniture represented labour and resources invested in its creation. Burning it was an acknowledgement that survival outweighed all other considerations. Even structural elements of the longhouse itself could be sacrificed. Interior partitions, non-essential beams, sections of the sleeping platform, these could be removed and burned if the alternative was freezing. This was catastrophic and rare, marking a household as having failed fundamentally in preparation. But it happened. Neighbours shared fuel when possible. A household that had gathered more than needed might loan or give wood to one that was running short. This generosity was partly altruistic but also practical. A household that froze to death could not contribute to community labour in the spring, could not defend the settlement if needed, and represented a loss of knowledge and continuity. But sharing had limits. No household could give away so much that it endangered its own survival. The calculation was constant. How much can we spare without risking our own future? The answer depended on how much remained, how many weeks until spring, and how much confidence the household had in their own estimates. Some communities maintained a collective fuel reserve, a pile of wood owned by no single household, but available to all in emergencies. This reserve was rarely touched, serving as insurance against unexpected disasters. A household fire that destroyed winter stores, an injury that prevented fuel gathering, an unusually harsh cold snap, these events could draw on the collective reserve. Maintaining this reserve required everyone to contribute during autumn. It was not voluntary. Communities that failed to maintain such reserves saw higher mortality during hard winters. Those that did maintain them survived longer and more reliably. Gathering additional fuel during winter was possible but difficult. Snow covered deadwood in the forest, making it hard to locate and heavy to transport. The cold made physical labour exhausting. Daylight was limited, restricting the time available for work, but when supplies ran critically low, people ventured out despite these challenges. These winter fuel gathering trips were dangerous. The cold sapped strength quickly. Getting lost in snow-covered forest could be fatal. Injuries far from the village during winter could not be easily treated. Groups travelled together when possible, providing mutual support and safety. Sometimes the wood gathered during winter was poor quality, damp from dawn snow, small branches that burned quickly, or frozen logs that required significant effort to split. But even poor quality fuel was better than none. It extended supplies by days or weeks, and those extra days could be the difference between survival and collapse. The psychological burden of diminishing fuel was significant. Watching the woodpile shrink created constant low-level anxiety. Every cold snap brought calculations. How much will this storm cost us? Can we afford to burn enough to stay warm? How much must we endure to make the supplies last? This anxiety was shared across the household. Adults bore it stealthily, making decisions about rationing and conservation. Children felt it through the adults' behaviour, the increased attention to the fire, the reluctance to add fuel, the cold that was no longer fully held at bay. Spring's arrival, or rather, the moment when it became clear that supplies would last until spring, brought relief. The crisis had passed. The household had calculated correctly, or luck had favoured them, or both. The remaining fuel could be burned more freely, knowing that warmer weather would soon eliminate the need for constant fire. Households that failed to make it through faced grim outcomes. Some relocated midwinter, moving in with relatives or neighbours and abandoning their own longhouse. This crowding was uncomfortable, but preferable to freezing. Others suffered through, enduring extreme cold with minimal fire. Emerging from winter weakened and ill, a few did not emerge at all. Every community had memories of winters when households fell silent, when the smoke stopped rising from a particular roof, when neighbours eventually entered to find the occupants dead or dying from cold and starvation. These memories shaped behaviour in subsequent years, driving more careful preparation and more conservative burning. The lesson was simple but unforgiving. Gather more than you think you need. Burn less than you want to. Watch the supply constantly. And never assume that spring will arrive on schedule. Winter lasted as long as it lasted, and the only certainty was that fuel, once burned, could not be recovered. The fire demanded attention. Not constant attention. No one stood beside the hearth every moment of the day, but regular, rhythmic attention. The fire was a living process that consumed fuel and needed replenishment. Neglect it for too long and it died. Tend it too often and fuel was wasted. The balance was found through repetition, through the development of patterns that became automatic. Morning began with the hearth. The first person to rise uncovered the banked embers, added kindling and revived the flames. This was not leisurely work. The longhouse was cold, breath visible in the air, and warmth was needed immediately. The fire came first, before food, before dressing, before anything else. Once the fire was re-established, attention could shift to other tasks, but throughout the day someone monitored it. This monitoring was often indirect, a glance toward the hearth while doing other work, a check of the flame height while passing by, an awareness of the heat level in the room. When the flames dropped too low, someone added fuel. This happened every hour or two during active daytime burning. The frequency depended on the type of wood, the size of the pieces, and how hot the fire was burning. Pine consumed itself faster than oak. Small sticks burned quickly. Large logs lasted longer, but took time to catch properly. Adding fuel was a practiced motion. A few pieces were selected from the nearby stack, carried to the hearth, and placed onto the existing fire. Not dropped, placed. The position mattered. Logs laid parallel to existing ones created channels for airflow. Logs placed perpendicular could smother flames if positioned poorly. The arrangement was intuitive to those experienced, puzzling to those still learning. The fire responded within moments. Flames adjusted to the new fuel, rising as they found fresh wood to consume. Heat output increased briefly, then stabilized. The person who had added the fuel watched for a moment, confirming the wood had caught properly, then returned to their other work. Cooking happened in coordination with fire management. When a meal was being prepared, the fire was built up slightly away, providing the heat needed for boiling, roasting or baking. Pots hung over the hottest section. Stones at the fire's edge heated for indirect cooking. The cook adjusted the fire as needed, moving burning wood to concentrate heat where required. After cooking, the fire was often allowed to settle back to a lower level. The intense heat needed for preparing food was not necessary for general warmth. Letting the fire reduce saved fuel while still maintaining adequate temperature inside the longhouse. Ash accumulated throughout the day. As wood burned completely, it left behind fine grey powder. This ash collected in the hearth, eventually covering the base and interfering with airflow if not removed. Someone, usually whoever was tending the fire at the moment, used a stick or flat stone to scrape ash to the edges, clearing the central burning area. The removed ash was not discarded carelessly. It had uses. Some was saved for banking the fire at night. Some was mixed with water to create lye for cleaning or soap making. Some was spread on pathways outside to provide traction on ice. The rest was dumped in designated areas away from the longhouse. Smoke management was part of the rhythm. Roof vents needed occasional adjustment based on wind direction and fire intensity. Too much draft and heat was pulled up and out too quickly. Too little and smoke filled the interior. Someone climbed to the roof periodically, perhaps once or twice a day, to adjust the covering over the vent opening. This adjustment was done by feel and observation. If the interior was too smoky, the vent was opened wider. If the longhouse was losing heat too quickly, the vent was partially closed. There were no measurements, no precise calculations. Experience taught what worked. Stones around the hearth required attention as well. They shifted over time from thermal expansion and contraction. Occasionally one cracked and needed to be replaced. Soot built up on their surfaces, and while this did not affect their function, sometimes they were wiped clean, more for tidiness than necessity. The evening routine was as structured as the morning. As daylight faded and the household prepared for sleep, the fire was assessed. Was there enough fuel loaded to last through the banking process? Were the logs the right size and quality? This evaluation happened while the fire still burned actively, allowing time to make adjustments. Children learned this rhythm through participation. A young child might be asked to bring one stick to the fire, a small task, but one that made them part of the process. As they grew, they brought more sticks, then learned to place them properly, then eventually took responsibility for checking the fire periodically. Mistakes were common during learning. A child who added too much wood saw the fire flare unnecessarily. One who waited too long saw the fire die down to embers. These mistakes had immediate consequences. Wasted fuel or a cold room which taught more effectively than any verbal explanation. Adults corrected these mistakes without harshness. The task was too important for carelessness, but everyone had been a learner once. Corrections came as demonstrations. Watch. I'll show you again. The child observed, then tried again, gradually building competence. The rhythm varied slightly from household to household. Some tended their fires more conservatively, allowing longer periods between fuel additions. Others maintained higher heat levels, adding fuel more frequently. These differences reflected personal preference, fuel availability, and the size of the space being heated. But the underlying pattern was universal. Check the fire regularly, add fuel when needed, remove ash periodically, adjust ventilation as conditions change. Bank carefully at night, revive immediately in the morning. This cycle repeated daily, a constant background task that continued through every winter the household endured. The rhythm became unconscious. Someone could be in the middle of another task, mending clothing, preparing food, caring for children, and simultaneously maintain awareness of the fire. They knew without looking when it needed attention. The sound of the flames, the level of warmth in the air, the quality of light, all provided information. Visitors to the longhouse could observe this rhythm but initially struggled to participate in it. The timing was not obvious to outsiders. When they added fuel, they often did so at the wrong moment or in the wrong amount. Household members corrected them politely, but the visitors' awkwardness highlighted how much skill was embedded in what appeared to be a simple task. The rhythm shaped time itself. Days were marked not just by sunrise and sunset, but by the fire's cycles. Morning was revival. Midday was steady burning. Evening was assessment and preparation. Night was banking and rest. This structure gave shape to otherwise formless winter days when external cues were limited. Breaking the rhythm had consequences. A household distracted by crisis, an illness, an injury, a conflict, might neglect the fire. It might burn too hot, consuming fuel wastefully, or too low, allowing the interior to grow cold. These disruptions were immediately felt, reinforcing the importance of maintaining the pattern even when other demands competed for attention. The fire's rhythm was the heartbeat of winter life. It was steady, essential, and unceasing. As long as the rhythm continued, the household continued. The two were inseparable. No household survived winter alone. The work of preparation, gathering fuel, repairing structures, storing food, was distributed across the entire community. Individual households performed most tasks independently, but the collective effort created a network of mutual reliance that increased everyone's chances of survival. Fuel gathering involved coordination. Families worked in the same forests at the same time, not because they explicitly planned it, but because the timing was dictated by the season. Late summer and early autumn were the optimal periods for cutting and drying wood. Everyone worked within those windows. This proximity meant information was shared. Someone who discovered a fallen tree told others. A section of forest with good deadwood became known. Methods that worked well, particular ways of splitting difficult wood, techniques for drying damp fuel spread through observation and conversation. The community's collective knowledge increased as individuals shared what they learned. Specialized skills were distributed unevenly. One person might be particularly skilled at identifying which stones were suitable for hearth use. Another might have developed an efficient method for cutting peat. A third might know precisely how to angle a roof vent for optimal smoke removal. These specialists were consulted when needed, their expertise contributing to the community's overall capability. Exchanges of labour were common. A household struggling to complete their preparation before winter might receive help from neighbours in exchange for future reciprocation. This was not formal contract, but understood obligation. Help given would be remembered and returned when the giver needed assistance. Elderly members contributed knowledge more than physical labour. They had survived the most winters and had seen the greatest variety of conditions. Their judgment about how much fuel was needed, when to begin serious rationing, or whether a particular winter was unusually harsh was trusted. This contribution was less visible than hauling wood, but equally valuable. Children contributed appropriate to their strength and skill. They gathered small sticks, carried light loads, sorted materials, and performed simple, repetitive tasks. This freed adults for heavier work and simultaneously taught children the skills they would need as adults. The division of labour was pragmatic, not ideological. Women's work and men's work overlapped significantly in winter preparation. Men more often performed the heaviest labour, felling trees, hauling large logs, heavy construction. Women more often managed storage, organised supplies, and oversaw food preservation. But these divisions were not absolute. Necessity overrode convention. If a household lacked adult men, women performed all necessary tasks. If women were unavailable, men did the same. The community watched each household's progress. It was impossible not to notice who was preparing adequately and who was falling behind. A household with an obviously small woodpile generated concern. Offers of assistance might be extended, though this required delicacy. No one wanted to imply that another household was incompetent. Some households consistently struggled. Perhaps they lacked sufficient labour, too many young children, elderly members, or someone injured. Perhaps the household head made poor decisions, burning fuel too freely or gathering too little. These households became known as vulnerable, and the community implicitly monitored them more closely. Collective structures supplemented individual efforts. The communal fuel reserve, if maintained, represented labour from every household. Shared storage buildings, granaries, root cellars were built and maintained collectively. Pathways between buildings were kept clear through shared labour, with each household responsible for the sections nearest to them. Not every household contributed equally. Wealthier households often contributed more to collective reserves because they had more resources to spare. Poorer households contributed more labour in proportion to their means. This imbalance was accepted as long as everyone contributed something. Enforcement was social rather than formal. A household that refused to contribute to collective efforts found themselves excluded from collective benefits. They would not receive help in emergencies. They would not be invited to share resources. Over time, non-contributing households either changed their behaviour or left the community. Individual failures affected the collective. A household fire that destroyed a dwelling mid-winter put additional strain on the entire village. The displaced household needed shelter, which meant crowding into neighbouring longhouses. They needed food and fuel, which had to come from others' stores. The community bore this burden, but not without cost. Similarly, individual successes benefited everyone. A household that discovered a new source of fuel shared that knowledge. One that developed a better method for preserving food explained it to others. Innovation in one household spread through the community, raising everyone's capability. The balance between individual and collective responsibility was maintained through constant negotiation. Households were expected to be self-sufficient but not isolated. They prepared independently but existed within a network of mutual obligation. The boundary between the two was clear in principle but often blurred in practice. Winter itself reinforced this balance. The isolation imposed by cold and darkness made each household responsible for its own immediate survival. No one could run to neighbours for help in the middle of a blizzard. But spring, with its return of mobility and interaction, re-established collective ties and allowed the settling of obligations accumulated during the cold months. Children absorbed this balance through observation. They saw their parents work independently on household tasks, but also saw them coordinate with neighbours, share information, and provide or receive assistance. These patterns shaped expectations about how communities functioned and what responsibilities individuals held toward the collective. The system was not perfect. Conflicts arose over perceived inequalities in contribution or access to shared resources. Some households felt they gave more than they received. Others felt excluded or judged unfairly. These tensions existed but rarely escalated to the point of breaking the community apart. The shared threat of winter was greater than internal disputes. Communities that maintained this balance, supporting individual autonomy while ensuring collective safety, survived reliably across generations. Those that tilted too far toward individualism saw higher mortality as vulnerable households failed without support. Those that tilted too far toward collectivism stifled initiative and discouraged households from exceeding minimum contributions. The optimal balance was not defined precisely, but it emerged through practice. It was felt rather than calculated, adjusted based on outcomes, and passed along as cultural knowledge alongside the practical skills of fire management and insulation. This cultural knowledge was as important to survival as knowing how to bank embers or stack turf. Without it, the practical skills alone were insufficient. Deep winter nights were still. The wind might howl outside or snow might fall silently, but inside the longhouses, movement slowed to near stillness. The day's work was complete. The fires were banked. The households had settled onto their sleeping platforms. The village rested. Smoke rose from roof vents across the settlement, thin grey columns visible against the night sky when the moon was bright. Each column marked a longhouse, a hearth, a household maintaining its small sphere of warmth against the surrounding cold. The smoke drifted upward, dispersing into the darkness. From outside looking at the village, little could be seen. The longhouses were dark shapes against darker landscape. Dim orange glows showed through cracks in doors or around poorly fitted roof vents, but these were faint, barely visible unless one was close. The buildings seemed to sleep as much as their occupants. Inside, the atmosphere was thick. Smoke hung in the upper portion of the longhouse, settling in layers. The air near the floor was clearer but cold. The sleeping platforms existed in a middle zone, above the coldest air, below the worst of the smoke. This was where people had learned to position themselves. The hearth glowed faintly beneath its ash covering. The glow was uneven, brighter in spots where the ash was thinner, dimmer where it was thicker. Heat radiated from the banked fire and from the stone surrounding it, continuing the work of keeping the interior above freezing. Breathing was audible in the quiet. The soft sound of many people sleeping, exhalations, occasional shifts in position, the rustle of furs and blankets. Animals at the far end of the longhouse made their own sounds. The shifting of cattle, the occasional bleat of a sheep, the snuffle of a pig, these sounds were familiar, not disturbing. Outside, the cold was absolute. Temperatures dropped through the night as the earth radiated away the small amount of warmth accumulated during the brief daylight. In extreme cold, the snow itself made sounds, crackling and popping, as its crystalline structure shifted. Trees cracked as sap froze and expanded within their trunks. The landscape was alive with the sounds of cold, but inside the longhouses, these sounds were muted. The thick walls, the turf roofs, the banked snow against the exterior all served as sound barriers. The interior was quieter than the exterior, a pocket of relative silence within the larger noise of winter. Sleep was not uniform across the household. Some slept deeply, exhausted from the day's labour. Others slept lightly, waking periodically to check on children, to listen for problems, or simply from habit developed over many winters. The elderly often slept poorly, waking frequently, lying awake in the darkness. Someone rose during the night to check the fire. This happened in most households at least once. The person moved quietly, trying not to disturb others. They approached the hearth, looked for the glow beneath the ash, assessed whether intervention was needed. Usually it was not. The banking had been done correctly, and the fire smouldered on without help. The person returned to the sleeping platform and settled back into their furs. Children sometimes woke from cold or from dreams. A young child might cry, and a parent would wake, pulling the child closer, sharing warmth until the crying stopped. Older children woke, realized they were cold, and adjusted their position or coverings without help. These disturbances were minor and brief. The hours passed slowly. There was no way to mark time in the darkness. The night felt long because there was nothing to distinguish one hour from another. The same darkness, the same cold, the same stillness extended for what seemed like an infinite duration. The village itself had its own rhythm at night. The individual households were independent but not isolated. The warmth from one longhouse mingled with the warmth from others in the spaces between buildings. The collective heat signature of the village created a microclimate slightly warmer than the surrounding open land. This difference was small, perhaps 1 or 2 degrees, but it was real. A thermometer, had such an instrument existed, would have recorded the gradient. Moving from the centre of the village toward its edges, the temperature dropped incrementally. The outer buildings were colder, the inner buildings warmer. The village's presence also affected wind patterns. The cluster of structures disrupted airflow, creating eddies and zones of reduced velocity. Snow accumulated unevenly, piling deep against some walls while other areas remained relatively clear. These patterns were predictable and were taken into account when positioning buildings and planning pathways. In the absolute centre of the village, in the most sheltered spot, the conditions were noticeably milder than at the edges. This location was often occupied by the most important structure, a meeting hall, a storage building, or the longhouse of the community's leader. This was not arbitrary, but reflected understanding of how the built environment modified the natural one. Predators avoided the village at night. The smoke, the sounds, and the presence of humans and dogs created a zone of exclusion. Wolves, bears, and other animals that might pose threats stayed away unless driven by extreme hunger. The village's defensive perimeter was not walls or guards, but simply the fact of human occupation. Occasionally something broke the stillness. A strong gust of wind might find a weakness in a roof covering and tear it partially loose, creating a flapping sound. A structural timber might settle, producing a creak or groan. An animal might become restless and thump against a barrier. These sounds woke some occupants briefly, but they quickly determined the source was not dangerous and returned to sleep. The coldest part of the night came in the hours before dawn. The earth had radiated heat for maximum duration, and the sun had not yet begun to warm even the upper atmosphere. This was when the interior temperatures in longhouses dropped lowest, when people pulled their furs tighter, when breath was visible even inside. But the village endured. Every longhouse maintained its banked fire. Every household remained in its sleeping spaces, conserving energy and warmth. The village did not fight winter actively during these hours. It simply persisted, waiting for dawn. And dawn eventually came. The darkness began to thin imperceptibly at first. The sky lightened from black to deep grey. The interior of the longhouses remained dark, but the quality of darkness changed. The night was ending. The first person to wake in each household stirred. They rose from their sleeping platform, moving stiffly from hours of immobility in the cold. They approached the hearth and began the process of reviving the fire. Across the village, this happened in every longhouse nearly simultaneously. The village was waking. Smoke from the roof vents changed character. The thin columns of night became thicker, more vigorous, as fires were rebuilt. The smoke rose straight upward if the air was calm, or bent and streamed if wind was present. From a distance, the village announced itself through this smoke, a cluster of hearths, a community of survivors, continuing another day. The fire in the hearth was older than anyone alive. Not the wood burned and was replaced continuously, but the fire itself. The flames that lit the longhouse on any given evening were descended through an unbroken chain of ignition from fires that had burned generations earlier. This continuity was not metaphorical. When a new household was established, fire was carried from an existing hearth. Live coals were transported carefully, protected from wind and weather, and used to start the first fire in the new dwelling. The new fire was literally kindled from the old, creating a direct, physical link between past and present. The practice had practical roots. Starting fire from scratch, striking sparks from flint and steel onto tinder, was difficult and time-consuming. It was far easier to preserve existing fire and share it. But the practice also carried symbolic weight. The fire connected the new household to the community it came from, establishing continuity across generations and between families. When someone married and established their own household, they often received fire from their parents' hearth. This transfer was deliberate, witnessed, and understood to mean that the new household was an extension of the old. The fire they cooked with, warmed themselves by, and banked each night was the same fire, in essence, that their parents and grandparents had maintained. This created lineages of fire, traceable in principle back through time. The fire in a particular longhouse might be descended from a fire brought to the region by the household's ancestors decades or centuries earlier. Every time the fire was banked and revived, every time a coal was carried to another household, the lineage continued. The responsibility of maintaining fire was understood as an inherited obligation. You did not merely keep yourself warm, you kept the fire alive, the fire that had been passed to you and that you would pass on. Letting it die was not just an inconvenience, but a break in continuity, a failure of duty to both ancestors and descendants. This responsibility was taught to children explicitly. They were told the fire's history, or at least as much as was remembered. This fire came from your grandmother's house when we built this longhouse. Her fire came from her mother's, who brought it from the old settlement near the coast. The details varied, but the message was consistent. This fire is not just ours. It belongs to a chain of people, stretching back and forward in time. Children learning to tend fire were learning to maintain this inheritance. When they practiced banking embers, they were practicing the preservation of something larger than themselves. When they failed and the fire died, they had not just created work for themselves, but had broken a continuity that had to be laboriously re-established. Restarting a fire from nothing, from flint and steel, was seen differently in this context. It was not just difficult, it was a reset, a break with the past. The new fire had no history, no lineage. It was a beginning, but one that erased what came before. This made letting the fire die a more serious failure than mere inconvenience suggested. Communities that relocated, moving to new land, abandoning old settlements, carried fire with them. The coals were transported in ember pots, carefully tended during the journey, and used to light the first fires in the new location. This ensured that even across geographical distance, the continuity was maintained. The fire in the new place was the same fire that had burned in the old. This continuity had practical benefits. It reinforced the importance of fire management, making it a cultural priority rather than just an individual task. It created shared responsibility. If your fire died and you borrowed from a neighbour, you were not just asking for convenience, but for help restoring your part of the community's larger fire lineage. The practice also had limitations and vulnerabilities. If an entire community was destroyed by disease, conflict, or disaster, the fire lineages were broken. Survivors who scattered and joined other communities adopted their new community's fire, integrating into different lineages. The old fire, in its historical sense, ceased to exist. But as long as the community persisted, the fire persisted. Through wars, famines, migrations, and generations of change, The fire in the hearth maintained its unbroken chain. It was one of the few elements of Viking life that could claim such continuity, a physical connection to the past that was renewed daily. Knowledge was inherited the same way. The skills of banking fire, selecting fuel, positioning stones, these were passed from parent to child through observation and practice. Each generation learned from the previous, added their own slight variations or improvements, and passed the modified knowledge forward. The knowledge, like the fire, was a living inheritance. Oral traditions, stories, songs, histories were often shared around the hearth. The fire provided light and warmth during these tellings, making it the physical centre of cultural transmission. Children learned their family's history, their community's values, and their society's myths, while sitting near the fire their ancestors had maintained. The fire was not just background, but an active participant in the process of cultural continuity. When an elder died, they died near the hearth. The fire that had warmed them through life continued to warm them in their final hours. After death, the body might be wrapped and removed, but the fire remained. It burned through the household's mourning, through the funeral rites and beyond. The fire outlived every individual who tended it. This outlasting created a kind of immortality, not for individuals, but for the household itself. As long as the fire burned, the household existed. The people changed, children were born, adults aged, elders died, but the fire continued, connecting each generation to all others. New households starting their fire from an established hearth were, in a sense, being adopted into this continuity. They became part of the lineage, their future link to the past they had joined. This created bonds between households that transcended individual relationships. A shared fire meant shared history, shared obligation, shared identity. The importance of fire in Viking culture is visible in their material remains. Hearths are central features of every excavated longhouse. Fire-cracked stones, ash deposits, and charcoal layers dominate the archaeological record. These physical remnants are evidence not just of practical necessity but of cultural centrality. The fire was the thread that connected past, present, and future. It was inherited from those who came before and entrusted to those who would come after. Maintaining it was not just about staying warm through one winter, but about honouring the continuity of the household, the community, and the culture itself. This understanding shaped behaviour in subtle ways. The care with which fires were banked, the seriousness with which children were taught fire management, the reluctance to let fire die, all reflected the recognition that fire was more than fuel and flame. It was inheritance, responsibility, and connection across time. The woodpile was low but still present. By late winter, months of burning had reduced the autumn's massive stack to a modest remainder. The logs that were left were often the least desirable. Knotted pieces that resisted splitting, wood cut too green and never properly dried, odds and ends saved from other projects. But they were enough. The household could calculate now with reasonable confidence. So many days until the weather would break. So much wood remaining. The numbers aligned barely, but they aligned. Barring a late storm or an unexpected cold snap, the fuel would last. This knowledge brought a kind of relief, though not comfort. Spring was not yet here. Only its approach was certain. The light was changing. Daylight hours were lengthening slowly but measurably. The sun rose slightly higher above the southern horizon each day. The change was incremental, minutes per day, but after months of the deepest darkness, even small increases were noticeable. The household's routine did not change dramatically. The fire still needed tending. The hearth was still banked each night and revived each morning. Animals still required feeding. Food stores still needed management. But the psychological weight had shifted. The worst was past. What remained was endurance, not crisis. Snow began to behave differently. The sharp, dry powder of deep winter gave way to heavier, wetter snow that clung and compressed. This snow melted partially during the day when sunlight touched it, then refroze at night into ice. The pathways between longhouses became slick and required careful navigation. The village emerged from its deepest dormancy. People ventured outside more frequently, tolerating the cold for longer periods. Small tasks that had been deferred through the worst of winter were now attempted. Roof repairs that could not wait until full thaw were completed. Tools were retrieved from storage and inspected. Preparations for spring work began in small preliminary ways. Conversations shifted. Households discussed plans for the coming months, what needed to be planted, which structures required major repair, whether livestock would be moved to different pastures. These were not urgent discussions, there was still time, but they marked the mental transition from winter survival to preparation for the active season ahead. The collective mood changed as well. The tension of deep winter, the constant monitoring of supplies, the careful rationing, the low-level anxiety began to ease. People smiled more easily. Laughter was heard more frequently, echoing between buildings. The village felt less oppressed, less constrained. But winter was not finished. Late storms still arrived, dumping snow and dropping temperatures back to midwinter levels. These storms were frustrating because they felt like setbacks, interruptions of the progress towards spring. But they were also manageable in ways that earlier storms had not been. The household knew they would pass. The supplies, though low, were adequate. The storm was temporary. The animals sensed the change. Cattle grew restless, moving more in their confined spaces. Sheep bleated more frequently. Even chickens, if the household kept them, became more active. These behaviours were instinctive responses to lengthening days, driven by biology that predated domestication. Preparations for calving and lambing began. Spring births were timed to coincide with improving weather and the return of fresh grazing. Pregnant animals were monitored more closely. Spaces were prepared for newborns. The household anticipated both the work and the reward. New animals meant future milk, meat, and labour. Food stores were nearly depleted. The grain was gone, or nearly so. Dried fish and preserved meat had been consumed steadily. Root vegetables stored in pits had either been eaten or had rotted. What remained was the minimum needed to reach the first harvests of spring: early greens, eggs from chickens resuming laying, milk from cattle after calving. Hunting and fishing became possible again as weather improved. Ice on rivers and lakes began to thin, though it was not yet safe to cross. Men ventured out on milder days, checking trap lines that had been set earlier, looking for game that was also beginning to emerge from winter dormancy. Any fresh food supplemented the depleted stores and was received with appreciation. The first visible signs of spring appeared. In sheltered spots, snow melted entirely, revealing bare ground. This ground was muddy, frozen beneath but thawing on the surface. Small patches of dead grass became visible. These were not dramatic changes, but after months of universal snow cover, any exposed ground was significant. Birds returned. The first sightings were reported and discussed. A raven overhead, geese passing in migration. These were early arrivals, scouts for larger flocks that would come later. Their presence confirmed what the lengthening days had already suggested. Winter was loosening its grip. The household began planning the transition out of winter mode. Which tasks needed to be completed before the longhouse could be fully opened and aired? What repairs could wait no longer? How would the space be reorganised once animals moved back outside, permanently? These questions shaped the final weeks of winter habitation. The fire remained essential. Nights were still cold, often below freezing. Snow still covered most of the ground. The hearth continued to burn, though perhaps not as intensely as it had in midwinter. Fuel consumption decreased slightly as milder days reduced heating needs. The remaining woodpile lasted longer than it would have weeks earlier. The psychological shift was perhaps the most significant change. The household was no longer simply enduring. They were anticipating. The future held work, hard, exhausting work, but it was work in warmth and light, not cold and darkness. The contrast made the coming labour feel almost desirable. Children became harder to manage as energy levels rose with the improving light. They had been relatively contained during the darkest months, but now they wanted to move, to play, to be outside. Managing this energy in the still confined space of the longhouse required patience. Parents looked forward to the moment when children could be sent outside without risk. Elders who had struggled through winter began to show whether they would survive to see another year. Some rallied with the improving conditions, their health stabilising. Others declined, the stress of winter having depleted reserves that could not be recovered. The household cared for both outcomes, celebrating recovery and accepting loss as part of the cycle. The village as a whole took stock. Which households had made it through successfully? Which had struggled? Who had lost members to cold, illness, or accident? These assessments were informal but thorough. The community's understanding of itself was updated, debts and obligations were remembered, and plans were adjusted based on who remained and what resources they had. The waiting continued. Spring did not arrive all at once. It came in stages, warmer days mixed with cold ones, partial thaws followed by Shrieyan, refreezing, gradual rather than sudden change. The household watched and waited, maintaining the routines that had carried them this far. But with growing confidence that those routines would soon no longer be necessary, the fire still burned, the hearth still warmed, the longhouse still sheltered, but the end was visible now, close enough to anticipate, far enough that caution was still required. The patient wait for spring was nearly over.